In many AI voice agents, you'll find that some lines never change. Scripts like, "Thanks for calling. Please hold while I look that up for you." Or, "Is there anything else I can help you with?" That stuff doesn't often change. Then there are other lines that depend on the answer that your model just produced. For example, maybe after calling a few tool calls. Now, ideally, you can reuse all the stock phrases and only spend your TTS tokens on the lines that are new. Which means some of the things your voice agents are saying will be pre-generated or should be pre-generated, and other bits can be generated on the fly. In this video, I'll show you how to do that with Cartesia, how to cache your stock phrases as raw audio on your system, and then join them or interleave them with live speech during a real call, so the caller hears one continuous voice on the line. So the first thing to know is that this is a client-side implementation pattern, because Cartesia does not store or cache or replay the clips for you. You generate a phrase once using TTS, and then you keep the audio bytes somewhere you control, maybe on your disk, on cloud storage, an edge cache server somewhere, wherever. And when that phrase comes up again, you play back your copy. Now, playing from your store or cache makes no API calls, so it costs no tokens in terms of the generation for TTS. And here is the idea that makes the whole pattern work. The bytes you store in your cache and the bytes that come back from a live TTS Cartesia call are the same kind of data. They're just bytes. Either way, it's just raw audio bytes, right? So that way you can interleave the cached audio and the TTS generated audio into a single audio output, and effectively you're concatenating bytes. That's it. Now, the second thing to know is that concatenation only sounds clean when the audio clips that you're joining together are correctly matched. Think of a video mashup, right? Something that you may have seen online, which often can be built from mismatched video clips. Some of them are older clips and some of them are new, so you have the grainy next to the sharp. And what that's caused by is different frame rates mushed together, right? Smashed together, and every cut shows. So audio is the same. If cached speech and live speech do not match on key attributes like the encoding type or the sample rate or the voice ID, and we said all this here in the doc, so you can see this in the Cartesia docs under text-to-speech, caching audio for stock responses. You can see that we need to have it exactly matched in all these key attributes. And if they're not matched, well, then the splicing is going to be quite janky. Now, this requirement also extends to the voice model, the version, and the language. So in production, my advice to you is that you should pin a dated snapshot of the model. So for example, you want to say Sonic 3.5, the 2026 0504 version. And that way, whatever you cached and created back in May 2026 still matches what you generate today in a live call. Now, one more detail on the shape. You will also see this when we start coding or when I show you the code, but it's important that when you first generate the audio, you want to ask the WebSocket API for the audio format to be in a container format, right? A raw container. And that is because this is a headerless PCM, pulse code modulation format. And that's important because other container formats like WAV or MP3 can wrap the audio bytes in headers. Now, those headers can get in the way of cleanly joining audio bytes together. Raw PCM, on the other hand, does not have headers, and that's why cached audio and live-generated TTS audio chunks can be concatenated seamlessly and sit next to each other in one buffer. Okay, now let's get to actually looking at what this looks like in code. You can also see this code that I'm going to be showing you in the actual guide in Cartesia doc. So you'll see both the scripts that are actually in the Cartesia guide at the moment, and you can refer to that. But step one is to build a cache of phrases that you want to reuse that you can see over here, right? You define a small map of stock phrases, and then you give each phrase a name. For example, you could call it the greeting, the hold, and the closing phrases. Now remember, we're using the same model, right? The same voice, the same output format that you're going to be using in production. So all of that's at the top of the file, and we'll reuse this in other scripts. Then you open a connection to the Cartesia TTS WebSocket, and you generate, for each of these phrases, you generate them once, and you write the raw PCM audio bytes into a folder. In our case, the folder that we're going to be saving to is called phrase cache, right? So we deposit or you save all the raw audio into that folder. So let's just run the script and see it do that. This is using UV, by the way, so the guide has full instructions on how you can set this up. Now that I've run this, I will see these three phrases have been set into three different files in the phrase cache directory, which now has closing, greeting, and hold, exactly as we see it here, greeting, hold, closing. So our audio cache is now ready in raw format. You'll see it's .raw files. Okay, now step 2 is what happens during an actual call with an end user. We are going to put together a response to a user that is a combination of cached audio phrases and live generated ones, right? It's an interleave sequence of phrases, but the output audio will simply be a single array of audio bytes. You'll see in the interleave TTS file, and you'll see this in the docs as well, that you simply keep under the hood one TTS WebSocket connection open the entire time, that you're stitching together the pieces of audio. But for each phrase in the interleaved sequence, you're checking, is this cached or do we generate by calling Cartesia TTS, right? So you're checking for each of the phrases, you're checking that. And then accordingly, your application's either going to load the audio bytes from your cache, or it's going to call Cartesia's API and get the live generated TTS audio on that same WebSocket that's still open, and then append all those bytes in sequence to the output byte array, right? So everything goes into this one ordered buffer here, the output buffer, right? Now at the end of the script, I've written in some logic that just basically saves that, converts that buffer to wave format so we can listen for ourselves, and we'll see what the caller is going to be hearing, right? So the caller is actually hearing different snippets of audio, right? These bits. And you'll see that some of it is pre-written cached phrases, and some of them are generated by the LLM. Now, for now, I've mocked that out, so I've just hard-coded 2 responses from the LLM, but in reality, you'll make the API call and get the LLM responses, right? And when these are put together at the end into this one output byte array, you won't hear the seam between the pieces of audio because it's just bytes being concatenated. So, enough talking, let me just run the script, and you'll see for yourself, right? So I'm going to write uv run interleave. That's the script. You'll see it in the guide docs as well. And what we would expect here is that it's going to spit it out into an output directory here. And then you see it's spliced wave, which is what the file is called here, spliced wave. So let's listen to it.
Thanks for calling Acme Support. How can I help you today? Okay, sure. Let me pull up order number AKQ 4245 for you. Please hold while I look that up for you, Elon. Okay, good news, Elon. Your order shipped yesterday and should arrive tomorrow. Is there anything else I can help you with?
So that was the closing, right? So you can see that the whole thing sounded very smooth. Now, of course, these are slightly disparate sentences, but the point is to illustrate how you can interleave these audio bytes together to use a mix of cached and live generated TTS audio, which is faster for you from a latency point of view, but also saves on token usage. Okay, there you go. So let's recap the pattern. First, we pre-generate stock phrases as raw PCM bytes that we store. And then during the call, when you're preparing your response for the caller, you interleave those pre-generated clips with live TTS audio and just concatenate the pieces of audio bytes. And then you just send those audio bytes to your front end or harness for it to replay back to your caller. Now, there are a few gotchas, and I've covered them here in the guide doc too. Remember, if your encoding type or your sample rate do not match, then you're going to potentially hear some weird clicks or distortions at the joins of the audio. And the same goes for your choice of voice, your choice of language, or the actual model version, the Cartesia Sonic model version that you're using. If you don't use the same ones, it could drift over time. Now, this example is a WebSocket only example, and you do not need to disconnect your WebSocket connection just to play back a cached clip. You'll see that in the code. That's a lot of overhead that you don't need to set it up and set it down. The cached playback does not need the WebSocket, but you can keep it open while interleaving the cached audio along with the generated audio. Okay. Now, keep in mind also that an idle TTS WebSocket connection to the API server will close after about 5 minutes of inactivity, which we've covered here in the docs. That is really the only reason you need to reconnect to the WebSocket. So just keep that in mind. Oh, and also we recommend that you cache full sentences, right? The Sonic models use the surrounding words for tone and humanness as well. So mid-sentence fragments can sound a little weird sometimes if the words don't have enough surrounding context. Finally, please take a look at the full walkthrough here with the code and the setup and the caching script and the interleaving script. It's all here in the Cartesia docs and guides. Start here, run both the scripts, and listen to the splice. And if you have any questions, comments, suggestions, feedback, anything, just reach out to us here or on our subreddit. We just love hearing from you guys and working with all the builders out there. All right, see you later.